talk about the Hamster gem. And it's self-described as that, efficient, immutable, and thread-safe collection classes for Ruby. So I'm going to go through what all that stuff means so that you can understand what the Hamster gem is. All right, so there it is blown up. Efficient, immutable, thread-safe collection classes for Ruby. First, what does collection mean? So collections are containers for objects, and Hamster provides a lot of different containers. First, it provides a tuple, which is an ordering of a fixed length and an ordering of, it has a specific order of the objects that are in it. So this is a tuple with 3 objects, the numbers 1, 2, and 3. There's also sets. Sets are a set of unique objects, so you can't have the same object twice in a set. It can only appear once in the set. And then they also have hashes, which are key value pairs. So you have a key, just like a regular Ruby hash. Vectors are kind of like Ruby arrays. So it's basically this list that you can efficiently access various indexes in the vector. It also has stacks, which are a thing where you push on an object and then you can pop off the top object. If you push on 2 objects, the second object is at the top. You can push it off, or pop it off. It also has queues, which is like waiting in a line for objects. And linked lists, which are these objects with pointers to another object, and so on. And Hamster has a pointer to the beginning of the list and the end of the list. So it's efficient to concatenate onto the end of the list or the beginning of the list. All right, next, immutable. So the collections are immutable. What does that mean? Immutability. This is some example Hamster code. First, you need to install the gem, just like any other gem. Gem install Hamster. And then the first line below that makes a hash. So we make a hash. It contains 2 key value pairs, name, Simon, gender, male. And then you can access it just like you would a hash in Ruby. So you can say person name, return Simon. But when you want to update the hash, you have to do something special, because you can't mutate it in place. Every time you use a method that would normally be a mutation in place in Ruby, collections, in Hamster, it returns a new collection that represents that mutation happening. So for example, if you call person.put with a new name, James, you have to assign that to a new variable, like friend, for example. And then the original one, you can see lower down here, person, is still named Simon. So person.put name James does not change what person is. It only makes this new one called friend. And same thing if you delete a record, for example, male deleted the name, and that is no longer, or that is still in person. So that seems like a lot more work, right? Like you have to make new variables and stuff like that. Why would we want to do this? Seems like a pain. All right. So I'm gonna try to sell you on immutability, which I guess we already had some, but we'll do that because I think that Hamster gem is really quite easy to use. Most of the methods look just like the collections you're using in Ruby. So why aren't you using it right now? I guess it's because it's not worthwhile for some reason. It must be a little bit more painful, or you haven't heard of it, something like that. But I'm going to try to sell you on why you should be interested and excited about immutability. Immutability is a good thing. All right, so this is a quote from Rich Hickey, the creator of Clojure. It says, "Mutable, stateful objects are the new spaghetti code. Hard to understand, test, reason about, a concurrency disaster." And Josh Block from Effective Java says, "Immutable objects are simple. Classes should be immutable unless there's a very good reason to make them mutable. If a class cannot be made immutable, limit its mutability as much as possible." You are already using a lot of immutable data, probably, if you're using some of these things I'm going to tell you about. If you're using Git, you're using an immutable data structure, the tree of commits is immutable. You append commits to it. You don't edit them in place unless you're doing something very sketchy, I would say. But if you do that, it's going to create a different one. It's not going to be the same one. Also, the Bitcoin blockchain is this immutable accretion of transactions, or however they're exactly called. And these things it's good that you can't go back and just edit the history of your Git repository way back and have it be okay. Like, it doesn't work that way. It changes what happened. It changes the history, and you know that it changed the history. Also, in Ruby, there's a lot of immutable things, but there is some immutable things. For example, symbols are immutable, and I think people like to use symbols quite a bit for the keys to hashes, and I think that's pretty good. So you're already using some immutable things. And there are benefits to the immutability. So if your code will become more readable if you use immutable things, because you'll be able to tell if methods you call are actually changing your objects, because they'll return a new object representing the change. Also, you'll have better concurrency properties and thread safety properties. For example, if you have some immutable value, you can show it to any other person doing processing, and they can't change it because it's immutable. So they can't edit your memory, and that's good because that solves a lot of thread bugs that you might have, because if you have two threads that are editing the same memory, they could get into some invalid state. But if they're looking at the same immutable data, they don't have that problem. All right. That was the sales pitch. I don't know if you're sold or not, but this isn't totally a talk about immutability, so I have to go on. Maybe we can talk about it later at PTs. All right. Efficient. So we decided we're going to use immutability. Let's make sure that we can do it in some efficient way. All right. So maybe you make a hash that contains 1,002 keys and value pairs, and then you want to change the name of your person hash that has 1,000 key value pairs, and and you can't mutate it in place. You have to make a new one, right? So does that mean you have to copy 1,000 keys and values? No. Efficient can also be said as persistent. That's another name. That's another technical term used, and the collections inside of Hamster are what's called persistent, and that's what makes them efficient. Here's a very simple example for how lists work and how you can make persistent collections for lists, specifically linked lists. I think it's maybe the kind of the simplest case, but this thing works for the other different collections too. So it gets used throughout this concept in the code. So for example, say you have two linked lists here, x's and y's, and you want to make z's, which is x's concatenated with y's, or x's plus y's. Then you make this new thing here, z's, which is a pointer to this thing here. And instead of having to copy y's, you didn't have to copy it because it's the black. Blue is the new stuff. So you had to make new 0, 1, 2, but then this was all the same from over here. And since you know that this is immutable, it's okay that you're just pointing to it, because you know this isn't going to change. The same thing works for trees. For example, if you had a tree like this, which I guess the tree structure isn't one of the collection structures, I think, but that they provide. But if you have a tree like this, I think what the tree is used underneath for the other collection structures, though. So say you have a tree like this, and you want to add a new element E as a leaf of F, so below F, then you can do something like this. So instead of having to remake the whole tree, you just have to remake 4 of the nodes of the tree. So the D prime, J prime, F prime, E prime. And you can use all the other parts of the tree. For example, you can see the left part of the tree, like the VAC, is just totally unchanged. So if you have a really big tree, you only have to change this one path through the tree down to the bottom node where you made the addition. All right, so that's what makes them efficient, because they can use these persistent collections. And thread safe. All right, so yeah, I said before, immutability gives you thread safety, but you only really get that if you know that your collection is thread safe, or your collection is immutable. And for example, or I should say, so the hamster collections are immutable, but what that means is the references are immutable, but the contents might be mutable. So you get to decide to put these contents into this collection, and what you decide to put in there might be editable. You might put in something that can be mutated. So if you really want to have thread safety, you need to make sure that your thing that you have, the collection, is immutable, which means that you put in immutable elements into it. And here's a little example of some code I posted in a GitHub issue for Hamster. I wasn't saying that they're doing something wrong, but I was just pointing it out in terms of clarifying their README. But anyway, basically, you have a value, the string A, and you put it into a hamster hash, where you have a key called :k, and it contains A, as expected. But then if you modify the memory of that, or if you modify that string, like the first character of the string, to be B, and you look at that hash, it contains B now as the value. That's because you can still edit these things if you choose to put in things that aren't immutable. There are some solutions to this out there. That, like, for example, I came across a gem called, I think it's called Deep9, that lets you freeze things deeply. So you can use that to do a deep freeze on the objects that you're putting into the collection. So that way you can have this kind of fully immutable thing. That's just kind of a word of warning. Anyway, yeah, so that's Hamster, efficient, immutable, thread-safe collection classes for Ruby. And I have some references here for things I read. I especially was very interested in these first two posts about immutability in Ruby. I think they make a much better case than the case I made, so I encourage you all to read them. And also the closure case is quite good too at closure.org/state. And you can find these links if you get to my slides, which is at my GitHub page, ryantm/lbrug_hamster. That's it.